Hi, welcome. Remember, assignments deadline is tomorrow, and test one's deadline is day after tomorrow. Coming to the next topic. Next topic is gradient of a scalar field and its physical significance. Okay. So in this video, I want to discuss about the gradient of a scalar field and its physical significance. So if psi of x, y, z is a scalar function of variable x, y, z, the product of del with psi, sorry, not psi, phi is known as gradient of the scalar function phi and is abbreviated as grad phi. That is, grad phi is equal to I into dou phi by dou x plus j into dou phi by dou y plus k into dou phi by dou z, that is equal to I into dou by dou x plus j into dou by dou y plus k into dou y dou z into phi. The term in the parenthesis is known as del operator. Okay. From the relation, it is clear that though phi is a scalar function, grad phi is a vector function. The first term represents the variation in the x direction, second term represents the variation in the y direction, and the third term represents the variation in the z direction. The gradient of a scalar function gives the unique direction in which the scalar function changes most rapidly. That is the maximum space rate of change of that function. Next, see the physical significance of gradient. Let us consider a metal bar whose temperature varies from point to point. So the temperature will be a function of x, y, z in the Cartesian coordinate system. Hence, temperature here is a scalar field represented by the function t of x, y, z. Since temperature depends on distance, it could increase in some directions and decrease in some directions. It could increase or decrease rapidly along with some directions in comparison to other directions. Okay. Here we are interested in the rate of change of temperature T with the distance as we move away from the starting point. Okay. See the picture. Let T1 be the temperature of point P and T2 be the temperature of point Q. So difference in temperature of point P and Q is dt, that is equal to T2 minus T1. Since dt is scalar and does not depend on the choice of the coordinate system, so we can conveniently choose a set of the axes so that we could write T1 is equal to T of x, y, z and T2 is equal to T of x plus dx, y plus dy, z plus dy, where dx, dy and dz are components of the vector dr. Okay. These are the dx, dy, dz are the small changes in the corresponding direction. And by the theorem of partial derivatives, the difference in values of t at two neighboring points can be written as dt is equal to dou t by dou x into dx plus dou t by dou y into dy plus dou t by dou z into dz. Okay. Treat it as an equation number 1, and the left side of equation 1 is clearly a scalar and right side of equation 1 seems to be the dot product of two vectors, and hence equation 1 can also be written as dt is equal to I into dou t by dou x plus j into dou t by dou y plus k into dou t by dou z dot I dx plus j dy plus k dz. Put it as equation number 2. and dt is equal, now dt is equal to del t dot dr, where del t is equal to I into dou t by dou x plus j into dou t by dou y plus k into dou t by dou z. Del t is known as the gradient of t. Clearly, del t is a vector quantity derived from the scalar field. So, equation 2 tells us that the difference in temperature between two neighboring points is the dot product of the gradient of t and the vector displacement between points. Okay. Since gradient of any scalar field is a vector, it, like other vectors, have magnitude as well as direction. Rewriting the dot product in equation number 2, we have dt is equal to del t dot dr, that is equal to modulus of del t into modulus of del r cos theta. So, this, we know this relation, correct, where theta is the angle between del t and dr. Okay. If we fix the length of dr and let it have arbitrary direction, the value of del t dot dr is maximum when dr is along the direction of del t, and it occurs when theta is equal to 0, giving cos theta is equal to 1. So, if we move along the same direction as the gradient, then function t changes maximally. Okay. So, the direction of del t is along with the greatest increase of t. Okay. These are explanation about gradient of a scalar field and its physical significance. So, based on this video lecture, prepare an essay for the following questions. What do you mean by gradient of a scalar field? Write the physical significance of gradient. You please write this essay in your notebook only. Okay. No need to submit. Okay. Thank you.